Hi, this is a demonstration of the BST homework. I think I forgot to cover the solution of this homework, so let's do this before the final exam so that you guys have this information as well for your benefit during the final exam. Um, so let's take a look at the C file first and find out which two subroutines we have to implement in assembly. And it's down here. One is called Add Bst Node, and the other one is called Default Bst Node. Let's deal with the Default Bst Node first, because even though it looks, to be the more difficult one, it's actually the easier one, because there's a really cool shortcut to it. And we'll take a look at the makefile, make sure that everything is specified here. Okay, and everything is indeed specified, except oh yeah, I got that fixed already here. Alright, so the first thing we want to do is to take a look at bst struct.c, because we need this program to print out the displacements into each individual member of the structures, and they're all defined in the .h file. So what I'll do is I'm going to use this trick using vi, so I can take a look at both files at the same time. I'm taking a look at the C file for bst struct, and also taking a look at the header file bst.h at the same time. And as I said, in the previous exam, this can be done by just using printf statements and not even need a macro. A macro is helpful, okay, if you don't want to have to retype a lot of stuff. So let's go ahead, let me just go ahead and do the macro here. And this time I'll try to do something that's even a little bit more fancy than the other one that we talked about in the class. So let's pound define offset, and in this case m for member. And we want to print the entire line. Let's see if I can do it, with the entire line, because the tricky part is a part of that is in the double quoted string of a printf. So in this case, we need to identify which structure we're talking about, and then which member of that structure, or at least the object name. Yeah, that's the structure. Okay, so we need s to be the name to be replaced, and we then need the pound underscore. I'll explain what pound means later. So let's see. Not sure that will work or not. Let's just deal with this first. Okay. So when I'm not sure about how whether something will work or not, I'll just write a very simple program to try it. If it doesn't work, then we know it doesn't work. So offset, we'll just say xy here, and note the xy are not quoted because they are parameter to the macro, and we'll just do it like this. Oops. And we say make bst struct, and it compiled. Well, at least it compiled. And when it ran, it did not replace the macros, because I think it has to do with those things being inside the double quoted string. So let me go off a little bit and do some quick research and see if we can do this. C3 processor macro in quoted string. And the answer is yes, we can do that. That's interesting. Okay. Alright. So this part makes use of a not so well known feature of C, and we'll give this a try. And once again, I'm not going to make this program really complicated yet. We'll just go ahead and make this as simple as possible. Aha! So it works now. Great. All right. So let me just kind of explain, how this part works. Um, the pound s, instead of just referring to parameter s, the pound in front of the parameter s means that we want to convert this into a string. In other words, it will be expanded in this case to quote double quote x and double quote. In C, if you can supply a whole string of double quoted strings, and if they are not separated by anything except for a space or a tab or line feed characters, they are considered to be on the same line. So that means your double quote x and double quote is the first part, and it's automatically concatenated to double quote underscore double quote. And of course, pound m is also replaced by double quote, in this case y, because y is the parameter passed, the argument passed to parameter m of the macro, and that will be expanded to double quote y and n double quote, and that is also concatenated with the rest of the string. So now we can go ahead and finish up the string by the equal sign, and then the actual number, for the calculation. That part we cannot actually, we cannot do these calculations inside the string, so we do have to depend on that here, and that will be the entire format string. And now we can supply the actual calculation part. The calculation part is forcing the member address of the member to be a char pointer first, and that would be obj.m, and we are forcing that to a char pointer, and then we subtract the address of the whole structure itself, and also cast it as a char pointer. And of course here I just forgot, I said taking the address of something, but I forgot to type the ampersand symbol. And there we have it. Alright, so this time we have to be a little bit more serious about it, and we have to do the pound include bst.h, and of course pound include sttint, so that we can have int32 underscore t defined. And I think that should be it. And over here we need, okay, there were a few questions regarding how do we have one single object that is referred to by the macro, and yet have the same, and then have to be able to define two structures. The two structures, we have two structures because one is called value and the other one is Bst node. For this particular homework assignment, if you do not separately define members for value, I don't think there will be any bad consequences in this case. But on the other hand, value as a structure can be shared amongst multiple structures to contain it. So it's always a better idea to make it a set of entries just for that particular object. A structure. Alright, so what we'll do here is we'll do exactly that. The first one is just a struct value obj, and the name of the variable has to be obj because the macro refers to obj and obj.m. So that part I cannot change. When we supply parameters to the offset, we have to first indicate the name of the structure, which in this case is value, and then we refer to the member, the name of the member, which in this case there's only one, which is I. And then the second thing we want to do is to print out the size of something. So in the fine tradition of making things as simple as possible, we'll just go ahead and do it this way. And in other words, I am just using the macro to handle just everything here in this case. So we'll just go ahead and refer to the size of the struct. Size of, since we're supplying the struct in this case, we'll just say size of s. And of course, don't forget to change the name of the macro. So we just call it size of. There we go. Now before I make any further changes, it's a good idea to make sure that at least this part works, and it does not. Well, it's not very surprising. Let's go to line 13. It's complaining size of has a problem after the expansion. And of course, I forgot to read the message before I go in. Value undeclared first use in this function. Note each undeclared identifier is reported only once. Okay, fine. Alright, so we still know it's line. Was it line 13? Yep, line 13, column 5. And it's complaining about this value here. And that value is not going to be used. Oh, okay, I know why. Because I forgot, I have to say the size of struct value, not just value. Alright, so let's try that one more time. And everything seems to be working. So this is great because now I have a template for the other structure, which is a little bit bigger and a little bit more complicated. But now that my macro is a little bit more capable, that also means that I don't really have to type as much as before, because now I just have to refer to the name of the structure, which is Bst Node, and just spell out the name of the members. Okay, the first one is actually V, and then the second one is P less, and the third one is P greater, and then we just need the size as well, so that would just be size of Bst Node, like so. And this time, I can just go ahead and make bst.inc the include file. Oh, okay, I got too cocky. It's complaining on line 17, obj undeclared. Alright, line 17. Well, that's very smart of me. Referring to the type, but forgetting to say what I'm trying to make. I'm making a variable called obj. Alright, very good. So now we have bst.inc. Everything looks good. Okay, so that's good. And now it's time to move on. Time to move on to the actual C code. And the actual C code, I'm just trying to figure out how to display the source code side by side. So I'll display the C code side on one side first, and then we'll display the assembly code on the other side. So this way we can do a side by side comparison. Alright, so Bst Node, default Bst Node is down here. And what we need to do is to implement it, and it's a good idea to copy and paste the code. Starting on line 72, ending on line 59. Yank. That's basically copy. Oops. And then we just paste. Oops. And this is from line 4 to line 11. So we'll say 4 to line 11. Substitute the beginning of a line by a space followed by 2 pound signs, and then another space. And now we have this subroutine commented out, but at least it is included here. And we'll have to define the labels first. Old EBP is 0. Return address is old EBP plus 4. We don't have any parameters in this case, but we do have one more entry, which is the return value address, and that's going to be return address plus 4, and this part is the convention of the compiler. Now the interesting part is I do have a local variable in the C code, and that's because in C I cannot directly access the area reserved for the return value. But guess what? In assembly I can. So this is really kind of cool because what I can do is not to use the local variable n at all, and do all my work with the area already reserved for the return value. And let me show you how we can do that. But before that, let's go ahead and deal with the entry code, which is push EBP, move ESP to EBP, and then the and is just the opposite of this. We'll move EBP back to ESP and pop L EBP. And now we're in the actual subroutine. Remember, we are not having a local variable n, and we'll deal with n dot p less equals null directly. Now, since we don't have a local variable n and we have the pointer to the return area, we can work with that directly. So what I'll do is I'll move or copy the return value address into EAX directly. So now EAX points to an area that is reserved as the return value of this subroutine, which is a struct BST node. And after that, to change the p-less member is really as easy as move L $0 to p-less open paren EAX. EAX is the base register because it points to the base of the structure, and p-less should have been BST node underscore p-less because it is a displacement of member p-less in a struct BST node. Okay, so when that's done, we do about the same thing to greater, like that. And after that, we deal with the V member. Okay, now this part is a little bit tricky because you have to not only indicate BST node underscore V, which gets us to member V of a BST node, but we also want to get to a struct value and the I member of a struct value. So you have to add those two together in order to get to member I of member V of this particular structure, which is pointed to by EAX at this point. And that's it. That really should do everything. Oh, well, I forgot one thing. Return has to be returned $4, because it is returning a structure, and it is a convention of the C compiler that you have the callee has to clean up the 4 bytes responsible for the pointer to the return value address. Okay, so that part is done, and I'll just be very brave here and not to test this subroutine and just move on to the Add Bst Node Subroutine. Okay, so in the C code, I'll do the same thing. I'll just go ahead and find out which lines to copy. It's line 23 all the way to line 50, 23 to 50. Okay, 23 to 50, yank. And then move back here, do a paste. So this time it's from line 3 to line 30. 3 to 30, substitute the beginning of a line with space, pound, space. And now we have the whole subroutine included. The first part is, once again, define the constants or the symbols. OEPB is 0. Return address, which is the call and return address, is OEBP plus 4. And then we have parameters. In this case, we have p3 is OEBP. Oops. Oh, this is bad because I just almost used the wrong thing. And then we have p node is p3 plus 4. We have some local variables here. I'll do the shortcut and not deal with the local variables. The local variables are needed only because we're doing this in C, but if we do this in assembly, there's actually no need to use the local variables. So we'll go ahead and deal with this one here. The first thing is we want to compare whatever p3 points to with null. Okay, and that can be done with move L p3 EBP to EAX first because we need one more level of indirection. So now that EAX equals to p3, we can do a compare long. Null is just 0, and then we compare that to whatever EAX points to. If it is not equal to 0, then we'll jump around. So we say JNZ to I think we have two if statements here. So this will be the outer else, and outer else is right here. And then remember, the else case also has to jump around to outer and if, and then we have to scroll all the way down to this part here, which is outer and if, and define the label here, outer and if. Okay, which is actually not something that we have to do. You will see later on why we really do not need to respect the structure of the conditional statement, because we're going to be a little bit lazy. Alright, so the first thing here is we want to copy p node, which is our parameter, to whatever p3 points to. Cannot do this in one single step. We have to separate it into two steps. If I don't want to blow up another register, because then I have to save and restore that, I can use a push out instruction. Push p node EBP onto the stack and then pop it back into wherever EAX points to, because EAX at this point is still pointing at it, EAX is still the same as p3, and we just want to store that to whatever EAX points to. Okay, the next one is we want to do this. Okay, so this time we have no choice but to move p node to EAX, because now we are dereferencing through p node, and it's almost the same as last time, using the indirect mode, except this time I cannot just use indirect because I'm accessing a particular member of whatever p node points to. So now I have to refer to bst node underscore p less, and then you'll specify EAX. So EAX is used as a base register with a displacement of bst node underscore p less. The next line is about the same, except we're dealing with greater. And here, this line is simplified because we already know that added equals 1 is really just specifying the return value. So we'll go ahead and just move $1 into EAX, and then we are done with it. We still need to jump to outer and if, because we still have the stack cleanup code after that, and I don't want to repeat that code here, so I'll just go ahead and jump to that label. So we are now done with the the then part of the outer conditional statement, and well, we can go ahead and try this out and see whether it works. And of course it does not. It's complaining on line 18, invalid operands for plus. Okay, I might have forgotten something that is really basic, such as including the header file that was generated. Yep, all the basic stuff is costing me. Okay, now it's complaining about line 21 and line 23 because we have undefined references to bst node underscore p less. Okay, so that means when I do something, when I created this, it's not done correctly. Bst node underscore p less equals 4. Bst node underscore p less undefined reference. I'm pretty sure what it looks like. It's bst node underscore p less, and oh, I forgot to pound include again, because I did it for one of the assembly files, but forgot to do it to the other one. Okay, now it should be good. Wow. Okay, so let's run it and give it a 5. Segmentation fault. Great. Okay, so we'll just run it inside the GDB. Run the program again, specify 5, and it is giving me a segmentation fault on line 14 of Add Bst Node. This is great information when you have a program that crashes. Don't try to debug it, using not using a GDB, because GDB tells you exactly on which line it crashes, especially in cases like this. That's an easy one because it tells me exactly where it crashes, and it's still early in the subroutine. So we just have to remember line 14, and then we'll take a look at that. Okay. Okay, we are crashing here, which is basically saying P tree is not a valid pointer. And that should never be the case. I mean, P3 should always be a valid pointer. And that tells me that something else is wrong. And I already know what's wrong with it. I forgot to push and push EBP and do all the setup for the frame pointer. Okay, push EBP, move LESP to EBP, and then do the same thing to get out. Do the exact opposite to get out. So move EBP to ESP, pop L EBP, and alright, let's try that again. 5. Okay, well, that works. I just type 5, press the enter key, and then type Control D. So this means the first part of the loop, conditional statement is working. And it's time to work on the second part. And this time I don't really need the C code anymore. And just focus on the assembly code because we have already copied and pasted the C code here. Alright, so this is the outer else, and here we have to call BST value compare first, and then depending on the result we'll do one or the other inside here. And the cool part is there are more shortcuts that we can take here, which is kind of cool. First of all, we have to call BST value compare, and that's not too difficult because we just have to move P3 ESP into EAX, push whatever EAX points to the stack, because that takes care of the second parameter, which is whatever P3 points to. And then we have to push L Bst Node EBP, and that's not dereferencing because we just want the parameter itself, not whatever it points to. And we can call the subroutine BST value compare, adjust the stack after that returns, add 8 to ESP to adjust for the 8 bytes that were used for the parameters. And now I don't need to store anything into CMP result. CMP result, that's right, because it's stored in EAX, and I can directly compare EAX to 0, which is done here. Okay, so CMPL $0 to EAX. Alright, so here is the really cool part, because I can just, with one single compare, it set all the flags already, and I can use multiple conditional branches without having to compare again. So in this case, I would jump around the then part of the inner if EAX is not less than 0. So we can say jump if not less than 0 to inner else if. Of course, it's a good idea to immediately specify where there is. So that is right here. Inner else if goes here. And also to specify that we better jump around to the end of the inner if. So we say inner and if, jump to that, which is going to be here. Inner and if. Alright, so I'm basically defining the structure of the conditional statement as we go. And here we have to call Add Bst Node again. The first parameter is pretty easy to deal with. It's just push LP node EBP. That's going to be pushed on the stack first because it's the second or the last parameter. Then we have to call this, kind of mumbo jumbo stuff here. But remember, the ampersand, which means the address of, is actually just easier because you have to get to the address before you can dereference it. So that means this is really nothing more difficult than what we have been doing. We just have to work with this thing from the inside out. Let's see, we'll move L P3 EBP into EAX. So now EAX is P3, and we'll go ahead and dereference that once. Move L EAX indirect to EAX. So now EAX becomes whatever P3 points to. Now we need to dereference it one more time, but this time when we're dereferencing, we are also trying to access a particular member of whatever EAX points to. and that's why we cannot just and plus we are calculating the address. So the other thing, so what we can do is say to is just to say add bst node underscore p_les. Don't forget the $sign because this is immediate, and we want to add that to EAX because EAX is the address of a BST node, and to get to the member p_les, we just add the displacement from the beginning of a struct BST node to the member p_les. So now EAX becomes the address of the member p_les inside the BST node. Push that also on the stack, and that's it. Those are the only two parameters. So we now call add bst node, and when it returns, we adjust the stack at 8 to ESP. So make sure the stack is now all balanced, and then we're supposed to store that in the local variable called added. But remember, added is really just there to specify a return value, and the return value is already in EAX. So it really is time to jump all the way out. But it's okay to follow this structure, because if we jump to inner and if, which is here, it just slides out to outer and if, which then you'll just get through the exit code. The other part of the program is about the same, but before I do any type of copy and pasting, it's a good idea to test to make sure that this branch is working first. And this branch is exercised when CMP result is less than 0, or whatever p node points to is what is less than whatever the pointer is less than the structure pointed to by the pointer that is pointed to by p3. So that means the new item is less than the old item. Okay, so that means I should be able to test this code by running it and only supplying numbers that are decreasing. So 5, 6, 5, 4, 3, 2, 1. Control D works. Okay, so that's good. That's reassuring. And now we just have to handle the other part, which is a copy and paste and replace some items. So let's see. We'll go ahead and copy and paste from line 45 to line 51. 45 to 51, yank, and then just paste it right here. The only thing we have to do is to change p_les to p greater. I believe this is the only part that it is referred to, so we just change that to p greater, and that ought to be it. That should be it. So let's go ahead and make BST again. Run that. Give it this time. We should be able. It should work with both numbers that are less than as well as greater than. We'll just make this fun. We'll just kind of interleave these numbers a little bit. Make sure that we exercise all the branches that we can exercise, and give it a return. Remember, the 0 is an artifact. It's always going to be there, so that's not. It is my bug, but it's going to be there. But it is not inside your subroutine, or the bug is not in the assembly code that you have to deal with. So as a result, I just have to fix main and relink it to your code, and everything should work. And the program is working, so this is all good. Alright, well, that's the end of the solution of the homework assignment for the BST homework assignment. I will go ahead and upload this video and send you the link right away.